To the 20-second video in the mathsonlinetuition.com videos where we're going through the C2 book. We start off with chapter 6, radian measure and its applications. Radians are another means of solving angles. Okay, you might have dealt with hitherto degrees, but we're going to switch it up a little bit. It's very important for you to appreciate radians because a lot of the time in the A-level mathematics curriculum we use radians as opposed to degrees. Degrees is more of a GCSE type of method to resolve angles, so we are using radians here on unless otherwise stated, and sometimes you'll have to convert between the two and you'll learn more about that later on. So you can measure angles in radians. As we know conventionally, degrees or 1 degree is 1 over 360. 360 degrees makes one complete whole turn. Okay, here in this particular situation we have that 1 radian is 180 degrees divided by pi. Okay, remember that 180 degrees divided by pi. So here you can see if the arc AB has length r, then the angle of AOB, okay, is 1 radian. Alright, please remember that. What does this mean? Well, this means that a radian is the angle sub-ended at the center of a circle by an arc whose length is equal to that of the radius of the circle. Okay, so we see here that we have 1c, alright, and here we have r, okay, being the radius, a and b being the length of the arc, okay, 1c or 1 radius, okay. Also, we have to appreciate that the whole circle, okay, has a 2 pi r circumference. Okay, as the circumference subtends an angle of 360 at the center, alright, we can see that we have 2 pi radians. Okay, so pi radians equals 180. Alright, we need to appreciate these subtle points to give us an appreciation of the wider picture. So here is an example of converting between angles into degrees. 7 pi over 8, okay, as we mentioned before, we know that pi is 180 degrees. All we have to do is multiply and we get the degrees. Likewise, 4 pi over 15 rad, converting it into degrees, 1 pi is 180 degrees, so all we need to do is multiply it by 180 degrees and we get the degrees. Very simple, very straightforward. Convert the following angles into radians. Well, we know what 1 radian is, okay, so 150 degrees multiplied by pi over 180, okay, gives us the radians 5 pi 6. Okay, so 1 degree is equal to pi over 180 radians. So very simple to appreciate those 2 points, and we write them out here just for you to recall. So we have that 1 radian equals 180 degrees over pi. Okay, so the formula for the length of an arc of a circle is simpler when you use radians. To find the arc length L of a circle, use the formula L equals R, and then you have theta, where R is the radius of the circle and theta is the angle in radians contained by the sector. Here is theta, the angle, here is R, and L is the length, okay, the arc length. Show that the length of an arc is L equals R theta. So the circle has a center 0 and radius R. The arc AB has length L. So what does that mean? That means that L divided by 2 pi R equals pi 2 pi. And this is the length of the arc, okay, over the circumference. And we have the angle AOB over a total angle around 0, around the center. Both angles are in radians. Okay, so you can see that the pi represents the radians, and this is how we get that particular formula. So the length of an arc equals, that should be L Okay. Find the length of the arc, and again you can see you have the radius, and you have the angle of 0.8 radians, which gives the arc length. Same thing here. You've been given this particular section of a circle, okay, and you have to express r in terms of theta. So we know that this is the parameter. Parameter are the edges added together. Alright, so now they've factorized, and then you end up simply dividing both sides by 2 plus theta, rearranging, and you have the following, okay, r in terms of theta. P here will just be some value. Now again, here is another question which just looks to resolve, okay, C, the length C, the arc length. And now you have these pieces of information, alright, and you also have this triangle here. Now we already know some of the rules. For example, here they use the sine rule depending on what you have. So we have two lengths, and we have now this angle, so we can see it's an isosceles just by the diagram, and we can appreciate now how to resolve it. So the answer is given here in radians, and then therefore you can figure out the final answer, the question of how to find the length of C. And here's some more questions for you to do. So as you can see, it's getting quite involved. 6.3, the formula of the area of a sector of a circle is simpler when you use radians. To find the area of A being this shaded part in pink, of a sector of a circle, use the formula A equals half r squared theta, where r is the radius of the circle and theta is the angle in radians contained by the sector. So again, all you need to do is plug in all the respective points that you have, materials, the values that you have, and you'll get this particular answer. Okay, same thing here, but now you have some numbers to play around with. Likewise, numbers to play around with, and at the same time you can do that in your own time. You can work out the area of a segment using radians. So the area of a segment of a circle of radius r is, so we have half r squared theta minus sine. So this was a sector, this is a segment, and you can see that the illustration here refers to this particular segment. This is a minor segment, it's a major segment. Minor because, as you can notice, it represents a small part of the circle. I would say an equal segment would be anything, any line, okay, going through the origin, going through the center, okay, that would illustrate two equal segments. But otherwise it's a minor segment and a major segment. And you can find the area by following this example here, which has been outlined for you very neatly. And likewise here, now this is just including areas, you're playing around with the area of the triangle, using radians and everything you've learnt before to appreciate the answer. Here are some examples for you to do. Come to the mixed exercises. And finally, as you can see, loads of examples. Finally, the summary of key points. Again, I didn't want to do too much on this particular chapter, reason being that it's quite easy for you to appreciate this in your own time. All I wanted to do was just discuss it and make sure that you appreciated what was involved. Again, all you need to do is convert radians, okay, into degrees and vice versa. Be able to appreciate the following geometric principles: the length of the arc and its formula, the area of a sector and its formula, and the area of a segment and its formula. Okay, throughout these different formulas you have different elements of information, and using those elements that you have, you're required to find the unknown. Now this is utilizing, perhaps as you saw in some examples, laws, okay, of some of the trigonometric signs, such as sine, for example. You had some angles and lines, and you had to figure out how to find the missing points utilizing previous information to get you to have all the elements to find the answer to the question at hand. So that's the end of chapter 6. We hope you've enjoyed this video, and we look forward to seeing you for the next chapter. Thank you and goodbye.